All right, so I left you to calculate this measurement right here and ask you to think about how you could calculate. We calculated this one to be 100. Let's try that again. 128. Yeah, it's going a little bit faster now. It's 128 degrees, and we know that these two angles right here are adjacent and they form a straight angle. So that means that they are supplementary angles, also called a linear pair. So since they're a linear pair, we can calculate that angle measurement by doing 180 minus 128. And you do that calculation, and I believe that gives you a 2 and a 7, 72. Oh, that does not look like a 2. So we get this angle right here to be 72. Okay, so we can bring this over here, and I'm going to place the vertex of that protractor right on that line. It's kind of hard, but I'm going to do it. And then bring the blue angle back over here, and it looks like it reads 43.3, but I'm going to guess that Springboard did not give me a 43.3 angle. It's very likely going to be a 43-degree angle. So angle 2 is 43 degrees. Okay, and no, you can't go by what it looks like, because to me, those two look like it would be the same. Um, and it didn't tell me, it did not tell me what kind of triangle it was either. So I don't know that it's an isosceles triangle or anything like that. Now, I can certainly measure angle 1, but I can also calculate angle 1 because I only need one angle measure for that triangle, and I already know two of them. So you take the two that you do know and you add them together. Uh-oh, I did this wrong. That's not 7. That's a 7. I bet y'all are going, this crazy teacher. I knew something was not right. Y'all heard me start talking slower, so I knew it wasn't right, and I certainly don't want to start over on this video. So we'll just fix it. So that's 52. So that means this is 52. Now 128 and 52 should add together to give you 180. All right, so that means that I messed up on this one. No, I didn't, because I measured that one. Okay, so now I'm going to add 43 and 52 together, and that's going to give me 95. And I'm going to add these two together. That's going to give me 95. So then I'm going to do 180 minus 95. No, this is still moving really slow. It's killing me. I can't hardly stand it to move this slow. Some of you who complain about how fast we go, though, are probably going, thank goodness she slowed down. Okay, so that gives me 85. And what that means is that angle 1 must be 85 degrees. Okay, that goes right there. Now, it's not real obvious because of the measures right here, but I want to show you something. I want you to look, take these two angles right here, okay, and we're going to add them together. So we're going to add 85 plus 43, and guess what you get? 85 plus 43, those two add together to equal 128. Does anybody recognize that number? The sum of the two remote interior angles was the same thing as the exterior angle. Now, in the next video, I will put this down on paper and measure it. No, I'm not going to do it. Let's do it right now. So let's click over here. And I took the picture from the textbook and I blew it up. And I got my protractor out and we'll measure, let's measure angle 1 this time. Okay, so to measure angle 1, I'm going to put the center of my protractor at the vertex. Okay, so I don't know if you can see there's a little dip right there, and so I've got it right in the middle of the dip. And then I've got the edge of it lined up. Okay, and then so from this side, I'm going to measure up right there. And so this is going 10, 20, 30, 40, 50, 60, 70, 80, and it's halfway right in the middle. If you're not sure, you can always take your protractor and extend that side on out so that you can read the measurement easier. All right, and we can see there that it's 85. So there's 80, 85. So that means that angle 1 right here is 85. And then we measure this one. We'd measure this one by doing the same thing. Measure it around. It doesn't quite go to 130, so it's 128. And we can calculate that one. We can measure angle 2. This time, though, we're going to have to start over here and go this way. So angle 2 looks like it is 40, I think it was 42 degrees. Is that what it was? 43 degrees. 43 degrees. And then this one, we calculated it was 52. So that's how you use a protractor. All right, let's switch back over here and scroll down, and it says what appears to be true about the measure of the exterior angle in relationship to the measure of the two remote interior angles. So here, what you would want to write, actually, I don't want to write on that because it's going so slow. I want to go over here and I'll write. So what do we want to write? We want to write, let me bring this down just a bit. We want to write that the sum of the remote interior angles are equal to the exterior angle. Okay, so be sure that you, the biggest thing here is being able to look at a triangle and decide which two are the remote. I'm going to stop the video and see if I can't find a page of examples And the triangles all turned around and upside down, just to kind of run you through and making sure that you can find them, because that theorem is really helpful in calculating um, angle measurements without having to do a lot of work. It just saves you some work. So I'll see what I can find and show you on the next video.